You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. After a cloud deployment completes successfully, services may technically be online, but performance issues can still emerge. These issues often show up as slow page loads, unresponsive automation, or services that take longer than expected to react to requests. Cloud systems may appear healthy from a status perspective, but users experience noticeable delays. These slowdowns can affect customer satisfaction, disrupt batch processing schedules, and result in timeouts that break workflows. In this episode, we focus on identifying, diagnosing, and resolving the root causes of performance degradation that occur after deployment is considered complete. The Cloud Plus exam emphasizes the candidate's ability to troubleshoot cloud performance issues related to latency and slow resource response. These scenarios may include interpreting monitoring dashboards, understanding bottleneck locations, and connecting observed metrics to likely root causes. Test items may involve identifying whether a delay is due to inadequate compute sizing, overwhelmed storage resources, network-level congestion, or improper scaling configurations. To prepare effectively, candidates must be comfortable navigating infrastructure metrics, understanding service dependencies, and recognizing how deployment design choices influence post-launch performance. The first signs of latency or performance degradation typically include slow web responses, repeated retries from clients, or timeouts in automated processes. Logs may reveal application-level delays, including failed retries, request queuing, or elevated back-end response times. Monitoring tools may show prolonged CPU usage, long garbage collection cycles, or high service response times. Users might report that performance is only slow during certain hours, or that delays are region-specific, suggesting either demand-related or location-based variance. Identifying the visible symptoms clearly is the foundation for deeper investigation. To pinpoint where performance degradation begins, monitoring of compute-related metrics is essential. Cloud services that are under-provisioned or overburdened may exhibit high CPU load, memory pressure, or I/O bottlenecks. CPU throttling may occur if instance sizes exceed their baseline capacity or if burst credits run out. Memory exhaustion can lead to increased swap activity or degraded garbage collection. Similarly, insufficient I/O operations per second on storage volumes will slow down read and write processes. Correlating these resource metrics with request logs helps identify whether infrastructure performance matches service demand. Storage is often a hidden cause of performance lag. If the deployed system is using lower-tier storage, such as magnetic disks or default general-purpose SSDs, then read and write speeds may be limited. Certain volume types provide higher throughput and lower latency, but at greater cost. Understanding the trade-offs between storage classes, such as GP2 versus IO2 on AWS, allows candidates to select appropriately based on workload. Metrics like disk queue length and throughput should be examined to determine whether storage is acting as a bottleneck. Network-related performance issues may result from bandwidth saturation, excessive hops, or mismatches in transmission unit size. Applications that perform slowly may be suffering from packet delay due to congestion, route inefficiency, or region-specific latency. VPC flow logs and tools like traceroute or pathpane help track how data moves between services. These tests can also reveal if network address translation, VPN tunnels, or security group rules are introducing overhead. Evaluating network throughput and delay is critical, especially in distributed or multi-zone deployments where latency may vary based on placement. Autoscaling is intended to improve responsiveness, but if configured improperly, it may introduce performance lag instead. If scaling thresholds are too conservative, additional instances or containers will not spin up in time to handle increased demand. Cooldown periods can delay scaling even after traffic spikes. On the other hand, if scaling is overly aggressive, It may introduce instability or cost overruns. Reviewing auto-scaling policy behavior during a load event, particularly scale-up delay and instance warm-up time, can help determine whether latency is being caused by delayed capacity expansion. Load balancers play a key role in managing traffic distribution and detecting unhealthy services. If a load balancer continues to send requests to slow or unresponsive backends, overall system performance will decline. Alternatively, if routing logic is unbalanced or sticky sessions are misapplied, some servers may receive a disproportionate number of requests. Reviewing health checks, back-end response times, and distribution algorithms allows candidates to determine whether traffic is being managed efficiently. The exam may include questions about interpreting load balancer logs in the context of latency symptoms. Application performance monitoring tools offer visibility into how requests are processed within the application code itself. Tools like New Relic, Datadog, or AppDynamics help trace the execution path of a transaction, from user entry point through API calls to database access. These tools identify slow database queries, poorly optimized loops, or third-party dependency delays. APM dashboards often correlate response time spikes with specific components or functions. Candidates should be able to interpret these traces and connect them to infrastructure-level behavior to build a complete performance diagnosis. Resource class or service SKU selection can be a silent limiter of performance. A service might be correctly configured but unable to meet demand simply because it is using a too small virtual machine type, a basic database tier, or a limited storage class. If services routinely hit performance ceilings during normal operation, this may indicate that the selected class was not aligned with actual usage patterns. Reviewing system behavior and matching it to known resource limits helps identify when an upgrade or resizing is necessary. The exam may test this by comparing usage metrics to resource specifications. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. A PI latency can be introduced not only by internal code but also by slow external or cloud-native services. If an application calls out to a third-party API or even a managed service within the same cloud platform, delays in those services propagate back to the end-user experience. To isolate these issues, synthetic tests and simulated transactions can be used to measure upstream response times. Monitoring tools that track HTTP status codes and retry patterns help reveal whether a specific dependency is introducing lag. When troubleshooting, it's important to differentiate between internal bottlenecks and external service latency. Application-level misconfigurations can silently degrade performance. For example, thread pools might be too small for incoming request volume, or caching settings may be improperly sized. Garbage collection behavior in languages like Java or Python can introduce jitter during peak activity, especially if memory leaks or object churn are present. Similarly, timeout values that are too short may cause retries that worsen congestion. After deployment, tuning these settings for the cloud runtime is necessary. Application configurations should be reviewed alongside infrastructure metrics to determine where fine-tuning is required. Database performance is frequently a bottleneck in dynamic web applications and API-driven services. Poorly indexed tables or inefficient queries can slow response times even when compute and network layers are operating correctly. If users experience delays during transactions or search operations, database logs should be examined for slow query warnings. Execution plans can reveal whether full table scans or unnecessary joins are contributing to the lag. Reindexing, query optimization, or moving to a higher performance storage tier are all valid remedies. The certification may assess whether candidates can recognize signs of database inefficiency from metrics alone. Long-running background tasks or queue-based workloads often suffer from throughput limitations that cause visible delays. In systems where asynchronous processing is handled by message queues or job schedulers, Performance depends on worker concurrency and queue depth. If the job completion rate falls behind request rate, the queue grows and response latency increases. Monitoring queue length, average job runtime, and scaling behavior of worker nodes helps determine whether the system can keep up. Scaling worker fleets or increasing concurrency limits are common solutions to post-deployment processing delays. When services are deployed across regions, latency may fluctuate depending on the geographic distance between components. Round-trip time for packets can vary significantly when traffic traverses regional or continental boundaries. Using tools like ping or curl with endpoint-specific tests allows cloud professionals to measure practical latency between regions. Synthetic probes can also simulate user experience from various geographic entry points. If latency is consistently higher in one region, placing workloads closer to users or enabling edge caching may improve performance. These techniques are especially relevant in global deployments. Rate limiting and request throttling mechanisms are often implemented to prevent service overload, but they can introduce artificial slowdowns if not properly tuned. If a service returns HTTP 429 or 503 errors, it may be rate-limiting incoming requests due to overuse or protective policies. Rate limits can exist on both the client and server side, with each affecting request flow. Reviewing logs for signs of rate-related errors and matching them to observed traffic volume helps clarify whether the problem is system overload or policy restriction. The exam may ask about interpreting these codes in a performance troubleshooting context. Caching effectiveness can have a major impact on how quickly services respond under load. If services are configured without caching, every request may hit the backend system, increasing latency and resource strain. Cache hit ratios should be reviewed to determine whether requests are being served from memory, disk, or the original source. Time to live settings that are too short may prevent cache retention, while overly long values can serve stale data. Implementing object, query, or content caching can drastically reduce round-trip times and improve scalability in cloud deployments. When users report latency issues, those reports must be mapped to actual performance metrics. Logging systems should be configured to include user session identifiers, timestamps, and request origin data. This allows administrators to correlate complaints with backend behavior, identifying whether slowdowns are isolated to specific services, regions, or usage patterns. Documentation of known performance limitations, as well as ongoing tuning plans, helps manage expectations. Understanding how to connect qualitative feedback with quantitative metrics is an important skill for cloud professionals being evaluated in the certification process. Troubleshooting performance issues after a cloud deployment is a multidimensional task that requires attention to metrics, configurations, and architectural design. Candidates must be able to diagnose slowdowns across compute, storage, and network layers, as well as within the application logic itself. Whether the cause is insufficient IOPS, slow scaling, unbalanced load, or inefficient queries, each symptom has corresponding data points. Success in the Cloud Plus exam depends on connecting these data points to actionable root causes and knowing how to adjust cloud settings to improve system responsiveness and stability. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.